In today's lesson, we are going to be looking at sketching quadratics with multiple transformations. So this is just going to build on the previous lessons, and we're going to be looking at, again, just sketching quadratics where we have more than one transformation. So kind of combining all the three different variables that we talked about, right? The A, H, and K. We're going to be combining kind of all three of them to look at how we can sketch it. And we're going to also look at a strategy that will help us sketch our transformed functions. So just as a little bit of review, two students graph the function f at x equals -2 times x plus 3 to the squared plus 4, yet their graphs are different. Which graph is correct and what errors occurred to produce the incorrect graph? So how we might start this, right? It might not be easy right away to depict which one is right or which one's wrong. But what we can do is we can look at our transformations and go from there. Again, remember our general form of our transformations, and I'm going to write it just above. The one we have should be f at x is equal to a x minus h squared plus k. So this general function helps us identify what the variables are. So I have a -2, a 3, and a 4. So I have an A, an H, and a K. So I have one of each. And I'm just going to move this down a bit so I can look more at my graph. So if I look at A, my A value is -2. My H value, again, remember opposite of what we see, is -3. And my K value is equal to 4. I'm just going to center this. So if those are my three variables, or my three parameters, or three transformations, or three values that cause transformations, I can now go through and figure out, okay, what transformations am I actually dealing with? So for A being -2, right, the negative tells me it's flipped. The 2 tells me it's stretched. Not too concerned about stretched by a factor of what. For right now, I'm just concerned, or at least I know that it's stretched. H of -3 tells me that we should be shift right, or not right, sorry, left, because it's negative, left 3, and K of +4 tells me we should shift up 4. And remember, this is all from our parent function. So if I want to quickly graph my parent function, I'm going to put it in purple. 0, 0, 1, 1, -1, 1, and then 2, -2, 4, +2, 4. So there is my, here is my parent function on the one graph. And here's the parent function on my other graph. So which graph looks like it's the correct one? And if we look at it, we should see a shift left and a shift up. So right from those two, I should be able to clearly see which one it is. A shift left and a shift up, that should bring me to a vertex. We can write that below. We should have a vertex of -3, 4. And the only one that has that is the one in blue here. So this is the correct one. So that is my correct graph, and this one is incorrect. The next step is to figure out what were the mistakes? What did the person do to get this graph? How did they get that graph? How did they move it down 4 or down 8 when we should be up 4? And if we think about the process, right, of what we're doing, what these variables are doing, right? The A of being -2, this means we multiply the y value by -2. The h value of -3 means we take the x value and -3, and the k value of +4 means we take the y value and add 4. So what this person actually did to get this incorrect is they didn't follow BEDMAS. right? They did not follow order of operations. And we should see that because if I add 4, right, that should be the last thing I do in terms of the y, in terms of multiplying. I should multiply first and then add 4, and that's going to cause it to go up. If I add 4 first and then multiply by -2, that's going to cause me to get this graph over here. So again, this was just kind of, and we did talk about this in the previous lesson, this was just kind of an example of why we want to make sure that we do follow BEDMAS when we're dealing with these types of questions. And again, that's really only going to apply to the y values because that's the only variable that has 2 parameters affecting it for our purposes. So remember, the only parameter that affects x values is h. A and k affect the y value. And we do have to follow BEDMAS when we're applying those transformations. So again, those things we need to remember when we're changing our variables or changing our key points. But there is something that's going to help us do that, and that's going to be the mapping rule. So the mapping rule is a set of operations that give you the points of a transformed function given the parameters of h and k. So the way this works, or the way this appears, is right here. So this is my mapping notation. I have my parent function, right? I have the points of my parent function, they're x and y, and they're going to go through a transformation depending on what my values are, what my variables are of the transformed function, and that is going to look like this. So what's going to happen is I'm going to take my x value and add h to it, whatever the h value happens to be. I am then going to, for my y value, multiply it by a and add whatever the k value is. So this is kind of a standard rule or a standard formula that you can follow to always come up with your transformed functions or your transformed points. So very similar to what we did in the previous lesson, now we're kind of just giving some formulas behind it so that we have something that we can always follow. So basically we're still going to need to know our parent function or those 5 key points, and then we're going to transform them based on the 3 parameters, the a, h, and k of our transformed function, to come up with our new table of values. So even if we're not quite sure what the transformations are specifically, as long as we can find our a, h, and k, we can come up with our transformed function and graph it. So let's look at an example. So here we have a function f of x equals 3x minus 2 squared plus 1. I want to come up with my I want to sketch the transformed function using mapping notation. So I'm going to need to use my key points and transform them and then graph them. So the first thing I can do is, looking at my transformed function, identify my different parameters, my a, h, and k, if there is any of those. And I do see 3 different sets of numbers, right, or 3 different numbers. So this should imply that there is an a, an h, and a k. And if we don't remember which one is which, you can always go back in your notes, look for that general function. F of x is equal to a x minus h squared plus k. So based on that, my a value is going to be 3. My h value is going to be positive 2, opposite of what we see. And my k value is going to equal 1. So now using that, I have enough information to graph my transformation or my transformed function. I have my parent function and I have the mapping notation. So this means that for every x value, I'm going to add h, which happens to be 2. For every y value, I'm going to multiply it by 3, and then I'm going to add 1. So now I can go through and graph my points. or not graph my points. I can come up with my points. So negative 2 plus 2 is 0. 4 times 3 plus 1 is 13. Negative 1 plus 2 is 1. 1 times 3 is 3 plus 1 is 4. 0 plus 2 is 2. 0 times 3 plus 1 is 1. And we should start to see a repeat. So 1 for the y values. Sorry, the x values, no. So 1 plus 2 is 3. 1 times 3 is 3 plus 1 is 4. And 2 becomes 4. 4 times 3 is 12 plus 1 is 13. So now I have my transformed function, so I can go through and graph that. Can't really graph 0 and 13, that's going to be kind of off the grid, but I can graph 1 and 4, and 2 and 1, 3 and 4, and I'm going to draw it something like this. So that is my transformed function. If I needed to, I could then go and look at and state what the transformations are if I wanted to, going back to the a, h, and k. Right, so here we have a stretch by a factor of 3. We shift right 3, and we shift up 1. So using the mapping notation, I was able to graph that or sketch it, and then I can go back and actually state what the transformations are just for my reference, and I should see that in the graph as well. Again, the next one is going to be the same idea. Again, we want to find our parameters, our a, h, and k, using that general notation to help figure that out. Here we have an a value of negative 2 over 3, an h value of positive 4, again opposite of what we see, and a k value of negative 2. So that will help me with my mapping notation to come up with my transformed function or the transformed points. So I will be taking x and adding 4. I will be multiplying y by negative 2 over 3. And I will be then adding negative 2 or subtracting 2. And go through and just plug in my values. Right? So my parent function was negative 2 for x, so negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. I can do the same thing for my y values. Take the 4, multiply it by negative 2 over 3. So 4 times negative 2 over 3 minus 2 gives me negative 4.6. Technically negative 4.6 repeating. All rounded to negative 4.67. 3, doing the same thing. 3, or for the point of 3, so I'm going to do 1 times negative 2 over 3 minus 2. I get negative 2.6 repeating, or negative 2.67. For the next point, the third pair, so 0. 0 times negative 2 over 3 is 0, minus 2 is 2. And then I should see a repeat for the next two. Negative 2.67, negative 4.67. Just seeing that repeat of values after this kind of 0 point, we should see a repeat. Right, so this is the 0 point, so that's kind of the vertex, and then I see that change, or that repeat in y values. So now that I have my points, I can go through and graph my transformed function. So at 2, we're at negative 4.67. At 3, we're at negative 2.67. At 4, we're at negative 2, 5, and then kind of just symmetrical on the other side. I can sketch my function, or the transformed function, And if I want, I can just roughly just quickly state what the transformations are. So it is flipped because of the negative, which we do see. It is compressed because it is it is spread out or looks fatter than our standard one. So it's compressed, and we can say by a factor of, or BAFO, by a factor of 2/3. Shift right 4, and then shift down 2. So those are the 3 transformations that we're dealing with. Last example, again, same idea. So just getting used to seeing different values, different functions, transform functions, so different variables to find. But again, same idea. We're finding our 3 variables or whatever parameters we might have. In this case, we do have all 3. So A is -2, H is -3, because again, opposite of what we see in the bracket, and K is -1. So if I go to my mapping notation from the transformed function, or for the transformed function, we will be taking x and subtracting 3 from it. We will be multiplying y by 2 and -2, and subtracting 1. I can now use my points, or my key points, to come up with my new table of values. So -2 minus 3 is -5. We have -4, -3, -2, -1. For 4, but now I can find my y value. So for 4, -2 times 4 is -8, minus 1 is -9. 1 times -2 is -2, minus 1 is -3. 0 times 2, or -2 is 0, minus 1 is -1, and then we repeat our values on the other side. And so again, once I get to this point here, this pair of points, the y values should start to repeat after, which they do, because 1 times -2 is -2, minus 1 is -3. So again, if you don't trust that, you can always go through and do the calculations for each y value. Now that I have my table of values, I can go through and plot my points. So -4, -9, or sorry, not -4, -5, -9, -4, -3, -3, -1, -2, -3, and -1, -9. There is our our transformed function. Again, we should see the transformations, and the 3 transformations that we have. One is that it's flipped, so we can easily see that. It is also stretched because of that 2 value, so it's stretched by a factor of 2. It is shifted left 3 units, and it's shifted down 1 unit. And again, we're just getting that from the A, the H, and the K. We can see that visually as well, especially the shifting left or right, or the shifting left and the shifting down. The stretch might not be as easy to see, but if we were to graph the parent function, again, just for sake of argument, we can. If we were to graph the parent function, we can see that the one in red does look a little bit skinnier, and we can also then clearly see the flip as well. So the main thing from this lesson, oops, I spelled shift wrong. The main thing from this lesson is just learning about the mapping notation. I'll scroll back up to now. Learning about this mapping notation that'll be really helpful when we're coming up with our transform function, or asked to sketch our transform function, because this is, again, an easier way to just kind of plug in the parameters and calculate what our new points for the transform function are going to be.